Okay, great. So okay, so I'll so did anyone get a chance to look at? I'll stay near the computer so that my voice gets recorded too. So did anyone get a chance to go to the Antlr page? So I put a link in the. Did you try it out? What they said? Okay, okay. So I'll just do that here. So going to Antlr page, then going to the documentation page. So here they have a link, getting started with Antlr. Okay, so just going there, and so I'm using a Linux system, so I'll be following this part. Hopefully everybody has Java on their computers. If not, please just install it. It's very simple. It's a very standard thing. Okay, so now what they have said is you download the Antlr distribution and put it on some folder. So here they have mentioned that user local lib is where you want to put it, but that's not necessary. You can put it in any folder that you like. Okay, so I have it here. So I have it in a folder called Antlr. That's all. Okay, so so wherever they have used this complete path to the Antlr distribution, instead of putting user local lib, you put the actual paths that you are using in your computer. So I won't be downloading this here. I mean, this particular command should directly work. That you download it and it will put the jar file, which is a Antlr distribution, in some directory of your choice. Okay. Okay. So I'll start from the next command, which says that export class path. So does anyone know what is class path? Okay, so class path basically says where to look for these Java executables. So Antlr is in Java. So you don't have to know a lot of Java to do this project. The Antlr thing is in Java. You will mostly be writing C-like code. Okay. But now the Java executables, when you want to execute something, you have to find the path where they are in, and class path says where it could be. So it could be, there could be multiple paths in the class path environment variable. Does everyone know what is an environment variable, by the way? Okay, so you just set your path and you're good to go. So I'll do what they have done here. So copying this. So instead of this user local lib, I will be giving my own path. Okay. So basically, what are the components of this class path variable? The first one is dot. So what is dot? Dot is the current directory. So so what you're essentially saying is, first look in the current directory for the Java executable. If you didn't find it there, then you can look in this directory. And if you didn't find it there also, you can look in whatever other things there are in there were already there in the class path variable. So that's what essentially is saying. Okay. Then they are creating, let me get a mouse. Okay, so after that, they are creating a basically a short form of a big comment. That's what Alias does. So I'll just do this. Here also I will replace user local lib by my path. And the third thing they have said, copying the same thing. Okay, so that's about what they had in the what it says to it takes to get started with Antlr on Linux. Okay. Now, so this is then there's a part called testing the installation. So I'll just copy from there. So yeah, so basically, if you get this kind of output which says that you have Antlr version 4.5 installed, that means it's working correctly. Okay. Okay, so now they have given a very small first example, kind of hello world type of example. They have called it the hello grammar. So I will go and I already have it. Okay, so so here they have created this hello grammar. Let's see that there. So this is in a file called hello.g4. So g4 is the file extension that Antlr takes. And here is the grammar. It's a very simple grammar. So it says that, so there's a rule called R. So the first, actually the third line, the left hand side of the colon symbol is just says R. So that means R is kind of a grammatical construct. And the right hand side says R is the word hello followed by something called ID. So what is ID is defined in the next line. It's kind of a sequence of letters. You can think of it as a simplified identifier. And there's a last line says WS. So WS here stands for white space. And basically it's essentially it's saying that space, tab, carriage return and new line all qualify for white space. And basically you skip it. If you were to encounter, if the parser or lexer were to encounter any white space, it should just skip. That's what it says. So it's a extremely simple grammar. Okay. Any questions about this? Okay. So now the grammar is written. The next step is to compile that grammar. So compiling the grammar in the case of Antlr produces a compiler. Okay. So it's called a compiler basically. So I'll do this Antlr hello.g4. Oh, okay, sorry. I named it Antlr 4, that's why it's not working. Antlr 4 hello.g4. So compiled without any errors. Okay. So now the next step that they have said over here is to, so basically compiling an hello.g4 with Antlr 4 create some Java files, .java files, which is basically the code for the lexer written in Java. So you just said these are the grammar rules. You didn't have to write anything in Java. Antlr automatically does that, creates a code that will do the lexical analysis, and that code that Antlr produces is in Java. So now that code has to be compiled with the normal Java compiler, which is Java C. Okay, so compile that. So what were the files that were produced? So these were the files that were produced right now. How did I tell? Just by looking at the timestamps. Okay. So all of these were produced like right now. Um, so these dot class files here, these are like intermediate Java bytecode files. So these will be really hard to read. These Java files here are in Java language. This tokens file here contains the tokens of the language. Okay, so let's see what's there. So basically, it says ID is one token, white space is another token, and they have given some numbers to these. Like ID has been given the number 2, and white space has been given the number 3, and so on. Okay. So hello is like the word hello. The string hello is another token. That's what it says. Any questions? Okay. So now the thing is like executing uh, the compiler that we created. Sorry, this is not what it is. Okay, so there are several parts. Actually, let me clear the. Okay, so there are several parts to this command. The first part is grun, which just runs the lexer or parser that you have generated. The second word is hello, which says which particular grammar do you want to be running right now. The third word is there is R. Okay, so what is R? R is basically the left hand side of the first rule in your grammar. It's like the start. You can think of it as a start symbol. It generates everything else. Okay. Minus tree is an option. So it says like minus tree means create the syntax tree. There are many other options that can go, but just giving you the example that they have shown on their first page. Okay, so now I have pressed enter, but it's waiting for some input. So it's waiting for an input program. So we have to basically compile a program, right? So the input test case is a program written in this language, not in C, not in Java, but written in this language, this grammar that we have defined in hello.g4. Okay, so let me just write something very simple. In that, they have also given that example over here. They have used this small string as an example of this language. So I'll do the same thing. Okay, and to indicate that I have finished putting in my input, I just press Ctrl D. So the output is textual output, which says that, okay, this hello.parrt matched with the R symbol. The other example they have given here is, instead of getting this textual tree, if you wanted to see it as a picture, then you would be running it with the minus GUI option instead of the minus tree option. So minus GUI, hello, so here is the tree. Okay, So these are very nice tools for you to check that you are doing the right thing when you are writing more complex grammars. You will not be writing something so simple. Okay. Okay. Um, so this is basically their entire page on how to get started with Antlr. Any questions so far before I move on to other things? Okay, the question is, do we need to set class paths every time? No, you don't need to set class path every time. If you want your machine to pick it up as soon as you log on, you should put it in your bash profile or something like that, bash RC in some cases. Okay. Any other questions? Do we need to do it in Ubuntu? Okay. So I am doing it in Ubuntu. I mean, Linux is very easy for setting paths and all these stuff that you have to do. You can do it in Windows if you want, but we will be testing it in a Linux environment. So it probably should be the same source file that works both in Linux environment and Windows environment. There shouldn't be any difference and shouldn't cause a problem. But we will be testing it in the Linux environment. Now, among Linux, do you have to use Ubuntu? No, I don't think so. You can use other Linux operating systems as well. Any other questions? Okay, so the question is, should R always be the first, the left-hand side of the starting rule? No, absolutely not. I mean, you can name it whatever you feel like, okay? Any other questions? Yeah, so the question is, does the grammar name and the file name have to be same? Yes, I think the grammar name has to be the same as the file name, and the extension has to be .g4. Other questions? Okay. What happens if the input program, the input test case, doesn't match the grammar in the file? So it's basically syntax error is there. So let's check that out. So basically, it's not the same thing that happens each time. So here they have flagged an error and said there is a missing hello at the beginning. It doesn't. So that's very nice. I mean, so this is a very nice error recovery. Typically, you will not find compiler generated tools to be so expressive. They will just say error and or silently crash and say, okay, you figure it out. But clearly, Antlr is doing a better job than most things. But yeah, you won't run to completion if you. Any other questions? Okay. So let's see a better grammar. Okay. So now, so in the first, for this first project deliverable, or whatever you call it, the task is to understand what are the tokens. I mean, the task is of course to also implement it in using Antlr, but the first mental task is to recognize what are the tokens in this language, because I've given you a grammar, I haven't explicitly said what are the tokens in this language. That is your job to find out what are the tokens in this language and then write an Antlr file that is able to extract those tokens. Okay. So if you missed some tokens, then you won't be coming up with the right answer. Any questions about this part? Okay. So I have written a small, very small example grammar, which is along the lines of the language that you got in your project, but it's a much smaller version of it. It's nowhere close as complicated. Okay. Okay. So here, the first line says lexer grammar example 1. So if you remember in hello, the first line just said grammar hello instead of lexer grammar hello. So the reason I have said lexer grammar hello is that I don't want to be concerned with parsing in this particular file. And for this assignment also, don't want to be concerned with parsing, just want to do lexical analysis, okay? So I won't be writing any of the grammar rules that are there in the language in this file. I'll just be writing the rules for the tokens and stop there, okay? So that's what the keyword lexer, at the first keyword lexer signifies that there are no parser rules, no grammar rules in this file. The only rules are the rules for recognizing tokens, okay? So the first one, can anybody say what it is? What token it's recognizing? White spaces, exactly. So, but the thing is, the interesting thing here is, it's recognizing a single white space, either one space or one tab or one new line. But remember that white spaces sometimes come in series or succession. So you may want to just ignore that, or you could use this as one token and then another white space token, which says there can be multiple of these white spaces back to back. So that's really a design choice. This is more to show you that how you can break up complexity. You can split complex token rules or regular expression patterns into multiple parts, okay? So basically the first line is the name of the token, right? So ignore the word fragment for now. The name is delim, for delimiter over here, okay? Then after delim, there is a colon symbol. So colon basically separates the left hand side and the right hand side. The left hand side is the name, right hand side is the pattern, basically the regular expression, okay? So the first regular expression for delim is just a single space. So the question is, can we write this whole thing in one line? So there are 3 different regular expressions for delim that I have specified using vertical bars to separate. Can we write those 3 in one line? Yeah, this is just to make it more readable. I have put every rule on a different line, okay? So the first regular expression for delim is a single space, second one is a single tab, third one is a single new line. Pretty simple, right? Any questions about this? This one? So white space is another token. Whatever is on the left hand side of colon is a token name. On the right hand side of colon is delim plus. That's a regular expression, if you remember. Now what is delim? Delim is the first one, okay? I'll come to this part a little later, the skip part, okay? So yes. Yeah, I haven't said what is fragment yet. Okay. Any other questions before I explain what is fragment? Okay. So fragment is a special keyword in Antlr. Okay. Fragment says that this is a helper token. This is not a token in itself. It is just a helper token which will be used to recognize an actual token. Okay. So this helper token names are not visible to the parser. They are only visible to the lexer in Antlr. Only the real tokens which do not have the fragment keyword at the beginning are going to be visible to the parser. Okay. Any other questions? Okay. So the next one is very simple. It's just a token for letter, for any letter of the alphabet. And I have also used the fragment keyword with letter because just by itself a letter is probably not a token. It can be used as a helper token. Later on, I have used letter in this identifier token. So identifier says it's a letter followed by letter or any number of letters or digits. Okay, I haven't used underscore here just to keep things simple. Make sense, everybody? Okay. So similarly, fragment digit is just the digits 0 to 9, and digit also has been used to recognize identifiers later on. Then I have used the token if and else for the keywords if and else. Then num is basically a integer number, so it says that one or more occurrences of the digit. Then I have used relational operator token for all kinds of comparison operators. I've used this for parentheses and braces. I have used the open paren, close paren, open brace, close brace. Any questions about this? Yeah, anything which doesn't have a fragment keyword at the beginning is a token that will be visible to the parser. Yes. Okay, so the question is that when we ran the hello grammar, we gave R, a small r as the starting rule name. What is the equivalent for this grammar? So let's execute it and see. Okay. So, oh yeah, skip. Before I go to execute it, what is this keyword skip? So skip basically is exactly what it says. It says that if the lexer encounters a white space, please don't send it to the parser, please throw it away. Okay, that's all. Any other questions? Okay, so let me go to executing it. So just like before, Antlr for example 1.g4 Java C example 1.java, then running it basically. So G run example 1. Now the start rule name should come. So in case of a lexer grammar, start rule really doesn't have any meaning, because in a parser grammar there is always a unique start rule. That is what generates the entire structure. But in lexer grammar it doesn't have any meaning, so they have a predefined start rule name which you just give no matter what your grammar is. So tokens is their start rule name, the default start rule name for lexer grammars. And in this case, let's say I want to generate tree won't make a sense in this case because there is no parser rule. So in this case, let's say I want to get the tokens get the tokens tree. So the option for that is minus tokens. Okay. So now I click enter. Now it's waiting for some input. Okay. So let's say what is an input. So giving it some input. So here is the token stream for if x equals to 0. So if is the first token, open parent is the second token, then there's x, there's equal to 0, close parent, and end of file is just a token that is always there. Now there are some numbers. So these are the strings that matched that particular token. So if you look at each line, so this first line, let's say, it has some information. So there is the string that matched that particular token. Then there is the token number, which says which particular token it matched. So how do you know what does 2 mean over here? So that is given in the .token file. So if I open example1.tokens, it has all the tokens and their corresponding numbers listed in there. So number 2 is the token if. Okay. So, and here we have the string if with the number 2. That means it was correctly recognized as a string for the token if. So also, I mean, similarly for these other tokens that have been there. So now the thing is that you don't have to, what I did every time I showed you was I typed in the input at the command prompt. You don't have to do that. You can write a file. You can have a file for your test case and you can provide that file as the input file. Okay, so let's try that. So I have this file. Okay, this is my text file, which has a valid grammar valid program in this grammar. So I will just run it again with this file. So here are the tokens. Okay. So now if you notice that I gave this IFA as one of the variable names. So instead of incorrectly thinking of it as if followed by an identifier called A, it has correctly matched it to the identifier. Okay. And if, on the other hand, has been correctly matched to a token if instead of the identifier token. So how did we do that? If you remember, there was a problem of overlapping languages between the token if and the token identifier. So how did we do that? How did we take care of that? So the way we took care of it was that I placed the rules for if and else before the rule for identifier. That is an implicit statement of precedence. Okay, so if I send this rule below identifier, then the matching will be incorrect. So IF will be recognized as an identifier instead of a keyword. So basically, although I didn't say anything explicitly about the precedence, just the positioning of the rules tells the tells Antlr what is the precedence. Okay. Yes. Right. So if I change the position of identifier and move it up, okay, IFA will still be recognized as an identifier. Yeah, that's the correct recognition of IFA. So IFA is basically not a case of overlapping languages. IFA appears in only one of the tokens, which is the identifier tokens. The word IF is a case of overlapping languages. So that will be taken care of by placing these rules correctly. Yeah, so I can show you that if I move, let me open this in a better editor. So opening this in the gedit editor, which is much easier to handle. Um, can everybody read this? Okay, great. So now if I move like what Rahul said, if I move this up above if and else, what happens now is we have to compile it again because it's a change in the grammar. So Antlr for our C example. Okay, so now I'm running the same test case. So now if you see that IF and IFA have matched to the same token number 2, which I am believing will be ID in this case. So just to check. So identifier is the token number 2. So we have gotten a wrong match basically. Okay. So any other questions? Any other questions? Okay. So this is I mean, coding wise, it's pretty simple. There's nothing much to the coding part in this particular project deliverable. The real work here to recognize the correct tokens, like what are the tokens in the language, because it's a much bigger language that you have in your project. So that's the real assignment, that you figure out what are the tokens in that language, and then writing that up, I don't think that will be a problem. Okay. Any other questions? Okay, so we will stop the demo now, and I have a few slides to cover, and then we'll call it a day. Okay. So let's